graph has a period of 2 pi. A cycle of sine graph goes from 0 through 2 pi. If you're good at midpoint formula or getting the half of these numbers, that'll be great, because between 0 and 2 pi, midpoint is a pi. Another midpoint is a pi over 2. Midpoint between pi and 2 pi, anybody? Between pi and 2 pi? 3 pi over 2. Just visualize your unit circle if you wish. Okay? Can you tell me what is sine 0? This is why I'm trying to get you guys with the numbers. Sine 0, you already may know, is 0. I use the 5-point methods to graph a function. Sine pi over 2 is 1. Sine pi is 0. 3 pi over 2, negative 1. 2 pi back to 0. Connect the dots. You have a cycle of a sine graph. One cycle. Watch it. It oscillates between negative 1 and 1. What is the period? Meaning sun rises at every 24 hours. The periodicity of the sun is approximately 24 hours. Yeah? Which means the sine graph originally repeats itself every 2 pi. We are just studying one cycle of it. If this makes sense, you know all the repeating cycles of sine, no matter where it starts and where it finishes. Okay? If somebody, by the time you get out of this class, says sine of some angle is 5, you're going to tell, wait a minute, not unless it's transformed. Okay? Sine of an angle, if you look at the unit circle, it goes between negative 1, 0, 0, 1. It oscillates between 1 and negative 1. Okay? If you graph this on a machine, not right now, later if you want to, it'll look like this. I have to be careful with this. Infinitely many cycles. They're all even right now, roughly put in perspective. They all are oscillating between negative 1 and 1. Right now we're taking one baby section right there to study sine. Okay? Don't just say one cycle is all it is, but we're just analyzing this a little bit. Okay? So its advantage is to take values near 0 origin. So the starting point of this graph, it starts at 0, ends at 2 pi. The period of it is 2 pi right there. One other thing people talk about a sine graph is its amplitude. Any physics people over here? Or anything about amplitude that you may know? How high, where is its crest and trough, is it? Or the peak, hilltop, and the valley swings between 1 and negative 1, so amplitude is a 1. Okay? Just take a moment and put yourself in a place where what can happen to this one cycle in a moment, in a little bit. Okay? In a little bit, what's going to happen? That graph maybe is moving elsewhere. Okay? And it's going between 2 pi over 3 and 7 pi over 3. I know. And it need not be between negative 1 and 1. It could be between 5 and negative 5. What has happened to my one cycle that I thought I knew? It suddenly scooted over by a certain distance, 2 pi over 3. So automatically some algebra is kicking in and it's saying, wait a minute, it's sine of x minus 2 pi over 3. Something like that will establish the fact that it's moving to the right. Yeah? And the 5 and negative 5 may prompt you to write a 5 up front, teaching you to design a function as well. Okay? Originally, by itself, sine has a period of what? 2 pi. Right now, do you have the algebra to tell me the distance between the starting and the ending point of this graph right here, as shown? So, to make sure you get a value, let me, for time's sake, call it k. 2 pi, the original period of sine, the last message for the week, for this week, 2 pi over k should be equal to the period that you guys called right now. How much was it? The period is 5 pi over 3. That's how you establish the importance of k value. You establish, make sure that the period is 5 pi over 3. What do? 2 pi over some number equal to 5 pi over 3, which means pi and pi cancel. This number is a 6/5. That number right up front is a 6/5. We'll talk a lot more about it. Okay? So, in a little nutshell, I told you the importance of number up front, number before the parentheses, and the phase shift. You all have a great weekend. Thank you.